Hey everybody. Been a while since the last episode. Busy with summer things all summer, having too much fun. And then, winter brings the holidays, but finally found a slice of time to present something new. And I hope you'll enjoy this one. We're going to be talking about how to integrate more complex devices into BruControl. In particular, in this episode, we're going to focus on the Atlas Scientific pH meter, but most of the content here will also work for their digital oxygen meter, and integrating these with BruControl will allow us to get real-time pH during the mashing process. And with the dissolved oxygen meter, we'll be able to monitor levels of dissolved oxygen both prior to the start of fermentation, which is what most people are really concerned about. But you'd also be able to get data on how that oxygen decreases as fermentation continues. So yeah, let's get to it. Integrating these types of devices is a little more tricky than a lot of things you might integrate with BruControl. BruControl, the firmware for it is written such that it can integrate natively certain types of devices. So it can integrate, pulse width modulation. It can integrate, analog devices that vary their voltage. But it doesn't there's no way to tell it how to integrate anything more complex that has some sort of proprietary interface. And in the case of these Atlas Scientific products, we need to integrate a completely separate circuit board, and this circuit board just sends strings. So when you're taking a pH measurement, the data that you're actually getting from this embedded systems board is just a text string that gives you the pH. So it's, 5.61 in text, for example, would be a single reading. So BruControl has no way it doesn't understand this natively. So the only way that we can integrate these types of devices is by having a separate Arduino microcontroller that's running independent of BruControl, and we write our own firmware running on that understands how to integrate with the Atlas Scientific device. And then we add Wi-Fi capability also to that firmware and use BruControl's data exchange API to set global variables that match the string data that we get back from the Atlas Scientific board. That, in a nutshell, is how we're going to do this integration. Expose global variables from BruControl that we can then hit with the BruControl data exchange API and have our own code running on completely separate microcontroller devices. So let's dig into some of the details. First, let's look at just how to wire one of these devices up with a separate Arduino board. And I have that here. Okay. So what we're looking at here is you have the Arduino microcontroller. This is an ESP32 dev kit device. I would strongly recommend this or something similar because they have both built-in USB, which makes them easy to program, but also they have built-in Wi-Fi capability, so you don't need any kind of external board to use Wi-Fi. It's all built in, and we have to have the Wi-Fi. So then the Arduino board is on the left in the picture, and then with the red light on it, and the green light is the embedded systems board that has its own firmware running on it from the factory that can interpret the Atlas Scientific sensor data. So it's pretty easy to wire up this external board to the Arduino. At the bottom there, you'll see one blue, it almost looks black, but it's a blue wire, and then a green wire right next to it. They're both very short, running from the Arduino board to the Atlas Scientific board. And this is serial send and serial receive, TX, RX. And when you're wiring these up, we're going to be using software serial in the firmware, so don't use the pins on the Arduino board that are actually labeled RX and TX. It's hardware serial. You just want to use general purpose I/O pins. You can use any two that you like, but they just need to be general purpose I/O pins. So I think I'm using, on this particular board, it ends up being pin 26 and 27. But the exact number is going to depend on the board you use. Then on the other side of the board is where we're actually getting our input from the sensor itself. And then also we have a pin that's running to ground over there. All in all, this is pretty well documented on Atlas Scientific site as well, all the pin assignments, so that you can wire everything up properly. I decided to just leave this on a breadboard, and it's glued to the inside of my case. This particular example here is the dissolved oxygen meter, so it's glued to the inside of my cold side controller case. But this setup actually works pretty well. I mean, I didn't really see much point of going through the trouble of actually soldering things to a prototype board, which they recommend not doing in their documentation anyway. So the breadboard worked just fine to get this integrated. And I'm drawing power and ground. These are just split off from a terminal block that's on the my main controller board. So at the end of the day, this really is not very complex. You just have two wires for serial in, serial out, and then the rest of the wires here are just for ground and power, and there's just one single wire that's carrying data from the sensor itself. On the right-hand side of the picture, that's just a voltage regulator that's over there. That's because I'm pulling 12 volts from my terminal block, and I need to get that down to 5 volts to power the stuff we have pictured here. And optionally, I think you can use 3.3 volts for this board as well, for the Atlas Scientific board, if your particular Arduino device wants 3.3 instead of 5. Okay, so moving on to the firmware. Let me go ahead and get rid of that guy, and we will bring up code window. Okay, so all of this is available on as a GitHub repository. I'll have it linked to the video comments, so you can download this at your leisure. This is all licensed under MIT, so no royalties. You just use it as is, and you can't sue me if it breaks something. So the first thing you'll need to do is you'll need to get the Arduino IDE. This is a free development tool for Arduino. You need this in order to get this software actually onto the chip, onto the device as firmware. I won't go into the download process for that. I think it's pretty straightforward. You can just Google Arduino IDE and find the necessary resources. From within the IDE tool, you're going to have to download a couple add-on packages. I think software serial is not included by default. And I believe HTTP client and Arduino JSON you might also have to grab. This is pretty straightforward to do. You can find tutorials on the web on how to grab these packages from within the IDE. There's actually a way to just checkbox what you want, and it'll download and install them. So you'll also, of course, need your the SSID for your Wi-Fi network. Put that in there, and your Wi-Fi password, you'll need to put that in there. And down here is where you can actually assign whatever pins you used for your serial RxTX, receive, transmit, that's what that stands for. Set those appropriately. Then you will need the IP address for your BruControl machine, whatever machine that's running on. You need to make sure that you explicitly open port 8000 to all traffic so that things outside of that machine can actually get through the firewall. And there are tutorials again on the web for doing that. You have to go into Windows settings and change a couple things, but it is relatively straightforward to do. Then another thing I would recommend too is most networks have a way to tie a machine to a reserved IP address. You need to do that. Otherwise, every time you restart your BruControl machine, it may be assigned a different IP address from DHCP running on your router. You don't want that to happen. You want the same IP address all the time because this is firmware. This is going to be hard-coded. It's not easy to change. You would have to, pull your device and re-download the software if it changed. So you don't want that hassle. So make sure you just set a static IP address for whatever device your BruControl is running on. And I would also recommend this device as well, and whatever other Arduino devices you have running, including the one that the BruControl firmware is installed on. Just make sure they're all static IPs so they don't change. Let's see, then we have a global variable here that we want to be able to access, which is mash temp. We'll go through creating these globals a little later in the video. Yours is probably going to be a different name, so you might have to change this. But the reason we want this is we want to be able to ask BruControl at runtime, okay, what is the current mash temperature? And we want that because we're integrating a pH meter, and that has temperature compensation. And there's a way for us to actually tell the Atlas Scientific sensor, okay, here's our current temperature, and it knows how to perform the compensation for that temperature and give us the correct pH reading based on that. Then we also need to know the global variable name within BruControl of however we want to expose the pH reading. So we have one variable exposed to read and one variable exposed to write. This is the one we're going to be writing the pH value to. These you can probably leave as is. Let's see, what other interesting things do we want to go over here? So we have a connect to Wi-Fi function. And at startup, this is just a routine to make sure we can connect to Wi-Fi. And if we can, we actually do print the local address. If we can't, then we just keep trying until we hit this timeout. And this is just to make sure we don't remain, in an infinite loop forever. Just keep in mind, you can have your device connected to USB when you're debugging this and actually see this printout. But once you hook this up to BruControl and have it running out of the box, you're not going to be able to see this unless maybe you did something like expose a variable from BruControl that you could write to write the IP address to, and then the device is connected. I didn't bother to do that. I haven't had any connection problems, but there are options here, certainly options for improvement. We have a function here for actually talking to the embedded Atlas Scientific board to set the temperature compensation. And here's the setup function. This function will be called every time the device is restarted. So we're calling our connect to Wi-Fi method here. We're also initializing our serial devices here. And then the loop method here, this just gets called continuously forever while the Arduino device is running. So we're checking our Wi-Fi status here. We have some code later on where if we lose our connection, we try to reconnect. We do periodic temperature compensation setting. Yeah, and as this loops, we're basically just continuously reading characters from the embedded board. And when we get a complete string, which is denoted by getting this line ending, then sensor string complete is true. And here's where we actually set the BruControl global variable to that string value. And those are really the highlights in here. You can go, it's pretty well commented, so you can go and study this and modify it at your leisure. But this is really all it takes to integrate one of the sensors. You know, this is pH, but as I mentioned earlier, dissolved oxygen is very similar. And now let's go ahead and move on to the BruControl side of this, and we can see how to expose these two variables that we're reading and writing to. Okay. So you can see on this guy, I actually have the mash pH reading currently in real time. Right now, the probe is just sitting in a bottle of buffer fluid. This reading is way off because the meter hasn't been calibrated for a while. So, because buffer solution should probably be closer to like 4. Yeah, let's kind of dive into what's going on here. So we can unlock this. We can look at this and we can see the name of this global matches what we were just looking at in code. So we can write to this value. And that's really all there is to it. I mean, you just need this global to write to, and in BruControl, this is done by going up here, and then we can just say add global. That's all there is to it. Then on the other side of this, we want to be able to read the mash temp to be able to do our temperature compensation. So I actually have a hidden global here, which is mash temp over here. And the thing is it's like, well, we already have temperature here. Why can't we just read this? Well, this is a one-wire temperature property. It's not a global, so we can't read directly from this. It's just not allowed via the BruControl data exchange API. Everything that you read or write to has to be a global. So what we have to do is go ahead and just create another global called mash temp. And then we have a script that's always running data exchange script. And all this script does is take values, local values, and copy them into the global variable every 3 seconds. It can be every 1 second, every 3 seconds, whatever you prefer. I thought every 3 seconds was plenty. So that's what we're doing. So you just have to make sure this script is always running so that you can migrate whatever non-global values you want to be able to read from globals in BruFather over. And that's really all there is to the BruControl side. Now, one of the big showstoppers that prevented me from integrating these devices for a long time is I could not figure out a way to actually physically hook them into my system in a good way. So, I mean, you can see in the picture behind me, everything is TriClamp on my system, with a couple exceptions here and there. But most of the places I'd want to plug in are TriClamp interface. And there was no way to do that for a long time with these Atlas Scientific devices. And I'm not sure when this actually got introduced, but I was just curious one day. I was looking around for some new toys, and I found Atlas Scientific had released a TriClamp fitting for their dissolved oxygen meters and also their pH meters. And so I've got the dissolved oxygen one here, and you can see, I'll hold it up here. The dissolved oxygen device just plugs into this adapter, and it gets pretty tight. There's like a ring in here with a silicone band that makes it nice and watertight. And I think they advertise that this can go up to like 100 psi or something. I want to double check on that, but it should be enough to where you can use this even on a pressurized unitank that's up at like 15 psi, and it shouldn't leak. And then just screws on there. You want to make sure it's tight, obviously. And then you can integrate this TriClamp wherever you want it. Just, put a T in somewhere, and then you have your dissolved oxygen and or pH meter integration point. So this is pretty great. I literally was waiting years for this because I couldn't find anything that would actually make a watertight under pressure seal on these devices until they released this. So thank you, Atlas Scientific. Right, so that is about it. I hope that was informative, and I hope people find some use in integrating these devices. I think it's a lot of fun to be able to see these things in real time, especially dissolved oxygen, because I feel like as home brewers, we typically just, we take our canister of pure oxygen and our carb stone, and we just let it run for the obligatory 1 or 2 minutes, and then we're like, cool, that must be good. But oftentimes we really don't know what the actual parts per million is. But now you can know. So happy brewing, and I will see you next time.